नमस्कार दोस्तों, इस वीडियो में हम लोग डिस्कस करने वाले हैं एनालिसिस। लेट्स से वी आर हैविंग अ प्रॉब्लम P और इस प्रॉब्लम P का मल्टीपल सॉल्यूशंस अवेलेबल है। मींस क्या, मल्टीपल एल्गोरिथम अवेलेबल है। लेट्स से S1 एक एल्गोरिथम है, S2 एक और एल्गोरिथम। अभी अगर हम लोगों को इन दोनों एल्गोरिथम में से बेस्ट एल्गोरिथम कौन सा है ये सेलेक्ट करना हो, तो इस चीज के लिए हमें करना होगा analysis of solution 1 and analysis of solution 2, right? So analysis on the basis of what? Analysis किस basis पे होना चाहिए? पैरामीटर क्या है एनालिसिस करने के लिए? So see, because whatever the algorithm we are going to implement that algorithm by using any programming language, and then we are going to run on the CPU. If you are going to run this solution, you will run on the CPU, right? So this CPU resource is very important here. Okay, so this is our first parameter, we can say, that is CPU time. So normally we say time, how much time it is going to take to solve the problem, right? The first parameter is time. Second parameter, when we are going to run this algo, we are going to run this solution, it will occupy some memory in the RAM at the time of running the solution. So that means again it is going to consume some resource of the system, and because RAM is limited, right? So that is why another constant, another parameter is going to be space, that is RAM, or you can say main memory, and time, that means CPU time, right? So these are two possible parameters on which we are going to analyze the algorithms. Now the first parameter, that is time complexity, that means CPU टाइम। जो हमारा एल्गो है S1 एल्गो और S2 एल्गो फॉर द प्रॉब्लम P, ये CPU टाइम कितना कंज्यूम करेगा। ओके, सो CPU टाइम क्या होना चाहिए? CPU टाइम फॉर द प्रॉब्लम P, व्हाट वी कैन से कंपाइल टाइम ऑफ दैट प्रॉब्लम, मींस व्हाटएवर दिस S1 इज एल्गो, right? To implement this algo, you will use some programming language, and every programming language is nothing but a compiler. So it will take some time to compile the code, because we are having high level code and we'll give to the compiler will convert this high level code into low level code. So this compiler will take some time at the time of compilation, that means compile time, and then run time of that program. So this is compiler and this is CPU, right? And this compiler is nothing but a software, and this CPU is again types of hardware. This is hardware, and that CPU can be different type, maybe i3, i5, i7, Pentium 4, and there are multiple variations of that configuration. And this software is of programming language of compiler, right? So we need to analyze these two parameters. One is time complexity, another is space complexity. If we particularly talk about time complexity, so we are going to analyze this compiler time and then run time. That is called analysis, right? To do this analysis, there are two possible approaches. One is a posteriori analysis and the another is a priori analysis. Okay, so priori analysis क्या कहता है? What you can do? No need to implement your code. First, if you are having a algo S1, so what you need to do is you can analyze your algo by some blueprint. Algo is nothing but a blueprint, how you are going to solve your problem. So you can analyze your algo. Okay, no need to consider this compile time, how it is going to take the compilation time, कितना time ले रहा है. Because if you are going to consider all these parameters, compile time and then run time, so when you are going to change your system, let's say you are working on a system whose configuration is i5, and then another system configuration is going to be, let's say, i9. So obviously configuration difference means speed may be difference होगा. Maybe i9 is going to solve x amount of instructions in a second, i5 is going to solve less than that x. right? So this is the actually difference. So whatever the solution S1 you are having, if you have implemented using some programming language, and then if you run this S1 solution on i5, it is going to give you a different result compared to S1 solution on i9. So that is why if you are going to ignore compiler time and other things, that approach is called a priori analysis, considering just about the solutions, just about the algorithm. We are not going to implement the algorithms, and we are not going to run and then check, okay, at the time of running how much time it is going to take. We are having algorithm. By seeing that algorithm, we can analyze the time complexity. We are not going to implement the code and then we are going to solve that time complexity when it will run in the actual scenario. Okay, whereas in the posteriori analysis, posteriori means बाद में, means solution. First you need to do implementation and then you will run on a particular system, and at the time of running you will measure everything. How much time it is going to take, depending on how much input it is going to take, how much time. So this posteriori analysis अगर आपको easily समझना है, so what you can do, रियल सिनेरियोज में देखिए ऐसा कौन सा एक्सपेरिमेंट होता है, लाइक परमाणु एक्सपेरिमेंट, उसको रियल टाइम में, अभी रिसेंट मूवीज आया था ओपेनहाइमर, है ना, साइंटिस्ट ने जो भी एक्सपेरिमेंट किया परमाणु बम के लिए, वो तो ऑन डॉक्यूमेंट हर चीज मेजर था, प्रेडिक्शंस की क्या इसका इम्पैक्ट होगा, बट देन उसके बाद भी they did one experiment, right? They did one experiment. So that is why they did posteriori analysis, right? So posteriori analysis will give you exact answer, because whatever the configurations you are having, whatever the compiler you are going to use, you are going to measure at the end when you have developed your code, and by running that code you are going to measure your time complexity. So that thing is not useful in the field of computer science. There are some differences, priori analysis and posteriori analysis. I will put on the screen. Okay.